I would like to discuss the new chapter, Module 1, Dyes and Pharmaceuticals. Purpose of this presentation is to introduce a new topic, dyes. Dear students, I am Dr. Digna Varghese. Contents of the presentation: dyes, requirements of a dye, applications of dyes, classification of dyes based on mode of application to the fabric, mention of indigo and alizarin. Dyes. Dyes are colored substances that are used to impart color to the fabrics and other articles like paper, leather, plastic materials, hair, cosmetics, and foodstuffs. A dye is a colored substance that chemically bonds to the substrate to which it is being applied. Dyes differ from pigments, pigments are finely ground solids dispersed in a liquid, such as paint or ink, or blended with other materials. Most dyes are organic compounds, whereas the pigments may be inorganic compounds or organic compounds. Requirements of a dye: it must have a suitable color. A colored material must get itself fixed to the fabric dye. When fixed to the material, it must retain even on prolonged exposure to sunlight, heat, and other atmospheric conditions. And when treated with water and soap during washing, this property is called fastness of the dye. It must be fast to other ordinary chemicals that are used during dry cleaning of dyed clothes. Sufficient solubility of a dye in water or in a suitable aqueous solutions is also preferable characteristics of a good dye because it makes the process of dyeing easier. Applications of dyes. Dyes are available in various forms such as granules, pastes, dry powders, liquids, pellets, and chips. In the current era, various dyes are manufactured to meet the requirements of each type of industries. A few common features and applications of colored dyes used in industries are discussed here. That is, dyes are widely used by industries for inks and tinting. Dyes are used by textile industries for cloth coloring. Dyes are free of heavy metals, so they are also used in cosmetics. They are resistant to heat, that is one of its feature, and it is also resistant to ultraviolet light, and it can conduct electricity. So these are some of the important applications and features of the dyes used in industries. Classification of dyes based on the mode of application to the fabric. Acid dye, basic dye, direct dye, wet dye, Mordant dye, disperse dye, Ingrain dye, and sulfur dye. First we will discuss about the acid dye. Acid dyes are highly water soluble and have better light fastness than basic dyes. The dyes that contain acidic functional group like SO3H, that is the sulfonic groups, and OH, that is the phenolic groups, are classified as acid dyes. The SO3H, that is the sulfonic acid groups, the textile acid dyes are effective, which are usually present as sodium sulfonate salts, that is SO3Na. It is regenerated during dyeing from an acid bath. So in the textile acid dyes, the effective one is sulfonic acid based dyes, which are usually present as in the form of sodium salt of sulfonic acids, that is sodium sulfonate salts. It is actually regenerated during the dyeing from an acid bath. The textile acid dyes are effective for protein fibers such as silk, wool, nylon, and modified acrylics. Protein fibers in that polyamides or polypeptide bonds are there. So the textile acid dyes are effective for silk, wool, nylon, and modified acrylics. Examples for acid dyes are orange 1. We can see the structure in the picture of orange 1, and orange 2, and methyl orange, Congo red, Martyrs yellow, that is a nitro based dye. It is an acid dye containing the phenolic group. Here the phenolic group is there. Here the SO3Na group is present in the case of Congo red. Methyl orange also the SO3Na, that is sodium salt of sulfonate salts are here, so it can act as a acid dye. Orange 2 contains also SO3Na, and orange 1 also contains SO3Na. So acid dyes are highly water soluble. They have better light fastness property than the basic dyes. All the acid dyes, there is acidic functional groups are present in the molecule, that is most of them contain SO3H. Among that, SO3 that is in the form of SO3Na, sodium salt of sulfonate, and also phenolic groups are present, that is OH. Orange 1, orange 2, methyl orange, Congo red, that will contain SO3Na as the acidic functional group, but in the case of Martyrs yellow, OH group is the acidic functional group. Acid dyes are suitable for dyeing fabrics that contain the functional groups like NH2, that is the primary amine, and NH, that is secondary amine functional group, or CONH, that is amide functional groups containing fabrics are dyed by acid dyes. The acidic functional groups of the dye, that is SO3Na or OH groups present in various acid dyes, and the basic functional group of the fabric, that is amine, secondary amine or amide functional groups of the fabric, interact to form a salt-like compound and get fixed to the fabric. So the color of the dye imparted to the fabric. The textile acid dyes are effective for protein fibers such as silk, wool, nylon and modified acrylics. Basic dye. Basic dye is a cationic stain and reacts with materials that is negatively charged. Basic dye contain the functional groups like amino group and substituted amino group. Examples: aniline yellow. We can see the structure of aniline yellow in the picture. It contains an NH2 groups, that is the basic group, and the two benzene rings are connected by an azo group, that is N double bond N. And the another one is butter yellow, that is also known as methyl yellow, that is the two benzene rings are connected by the azo group and there is Nr2 type functional group. And the next one is malachite green, and the color of malachite green is shown here. And in the picture we can see there is N plus double bond CH3 CH3 and Cl minus. So it is in the cationic form. And the other example for the basic dye is rosanilin. Its color is red. Here two NH2 group and one NH2 plus Cl minus group. So it is in the cationic form. At a chemical level, the basic dyes are typically cationic and display cationic functional groups. In acidic solutions, they form water-soluble cationic salts, that is NH3 plus, NHR2 plus, etc. In acidic solution, there is H plus, so it is reacts with the cationic salts water-soluble compounds to form NH3 plus. If aniline yellow dissolved in acidic solutions, it will converted to NH3 plus. If butter yellow is reacts with the acidic solutions, it will converted to NHR2 plus. These cations interact with the anionic or acidic sides of the fabric and get attracted and fixed on the fabric. That is the chemistry behind the dye. These dyes are used to dye the reinforced nylons. That is, we can see the reinforced nylons in the figure, and the polyesters. Polyesters also dyed by basic dye. Next, classification of dye based on the mode of application, that is direct dye. Dyes can be applied directly to the fabrics from a hot aqueous solutions. Example, Martier's yellow, that is one of the example for acidic dye. Here we can see the Martier's yellow. It can apply to the fabric in a direct way, because when the fabric is kept in the hot aqueous solutions, directly we can use the dye to this solution. It will fixed on the fabric. It can apply wool, silk and nylon. Another one is Conco red, that can be applied to the cotton. It is one of the example for acidic dye also. We can fix the dye in a direct way to the fabric, so it is also under the category of direct dye, that is applied for the cotton materials. Another one is malachite green. This is an example for basic dye, and it can also apply for the wool and silk materials. So it is also apply the directly to the fabric. Another one is watt dye. Watt dyes are applied to the fabrics in a vat in their colorless soluble reduced state called leuco compounds, and then are allowed to undergo oxidation in air to regenerate the dye in an insoluble form fixed to the fiber. Dyes which are applied to the fabrics in a large vat, that is an apparatus, in their colorless soluble reduced state, that is known as leuco compounds. First, it is applied to the fabrics and forms a colorless leuco compounds, that is it's a reduced form. When it is undergo oxidation in air, that means when the fabric is dried on air, it will undergo oxidation reaction, and to regenerate the dye color in an insoluble form. First it is in the reduced form, that is in the soluble form, then it is converted to the insoluble form, that is fixed to the fiber. Dyes are insoluble in water but soluble in their reduced state. Example, indigo, that is used for cotton fabrics. The structure of indigo is shown here. Indigo is an indigoid dye, that means it contains the indigo group. Indigo group is that shown here, a benzene ring and a 5-membered ring which contain CO group, C double bond CH2 group, and there is heterocyclic ring system, that is NH is the, or N nitrogen is the heteroatom here. This is the indigo group. So this compound is known as indigoid dye. Here we can see the structure of indigo. Applications of the indigo dye is, it is a vat dye. To dye the cotton denim cloth for blue jeans, we know the color of denim jeans is blue, that is actually dyed by the vat dye indigo. To dye, it is also used to dye the wool and silk. Indigo carmine, that is a derivative of indigo, that is used as a food colorant, that is a food additive used to enhance the or imparts color to the food, that is a food used as a food colorant. Indigo carmine, that is a derivative of indigo dye. Mordant dye. Next, classification of dye according to the mode of application to the fabric, that is mordant dye. Dyes that have very poor affinity for the fabrics but form insoluble colored metal complexes called lakes on the fabric, pre-soaked with the solution of a metal salt called a mordant. We know a metal complex that is there is a central metal atom, and there is surrounded by ligand. Ligand is actually an organic compound that will donate electrons to the metal atom. Metal is in the positive or neutral state, and ligand, the group of atom attached to the metal which can donate electrons to the metal atom. So there is a bond formed between the metal and the ligand, that is coordinate bond. Coordinate bond is a special type of covalent bond. In covalent bond, both the atoms are sharing electrons, that we can see in a general form. If AB is a covalent compound, here electrons are shared between the two atoms, that is A and B, that one electron from A and one electron from B donate or shared and forming a new bond, that is covalent bond. But coordinate bond is a special type of covalent bond in which the bond is formed by the donation or sharing of the electrons, that is donated by one atom. Here the ligand is donated or sharing its two electrons to the metal atom and forms a coordinate bond. This type of compounds are known as complex or coordination compound. So here the Mordant dye that have a very poor affinity for the fabrics but form insoluble colored metal complexes, that is known as lakes. Insoluble metal complex, that is known as lakes, on the fabric that is pre-soaked with the solution of a metal salt, that is called a mordant. Dyes actually that have a very poor affinity for the fabric, but fabric is pre-soaked in the metal salt solution, so that is called mordant. And the dyes that form insoluble colored metal complexes, that is known as lakes. The mordant, that is the metal ion, that is known as the metal salt solution, that is actually known as the mordant fabric, that is when it is pre-soaked into the metal salt solution. In one hand, the dye, on the other through coordination linkage, in which both the dye and the fabric acts as ligands. Here we can see there is an alizarin dye is an example for the mordant dye. Its color is red, but the color can be changed according to the metal to form a complex. Here the aluminum metal is shown here. The alizarin is act as a ligand, and also the dye also fabric act as also a ligand. Both these attached to the metal atom and forming a complex. Here the mordant is the metal ion, and insoluble colored metal complexes, that is fully known as lakes. Okay, so cotton fabric and the dye act as ligand to the metal ion. Here the oxygen, that is the lone pairs of the oxygen electrons. Lone pairs means the electrons that are not taking part in the bond formation that electron pairs are known as lone pairs that can donated to the metal atom. Here the oxygen atom, here the oxygen atom, that is from the OH group of the alizarin, and it removes H plus ion and form a strong bond, that is O minus, to the aluminium 3 plus ion. Here also the cotton fabric contains OH group and it also form a strong bond with the O minus. Aluminium is in the plus 3 oxidation state. Aluminium is in the plus 3 oxidation state. So one OH from this and second one from this OH group and third from this OH group, that will eliminate 3H plus and forming 3 O negative ions that will neutralize the molecule here. So this forms a Mordant die, that means it forms a metal complex or a coordination compound. Actually the dye, that is alizarin, has a poor affinity for the fabric, but when the cotton fabric is pre-soaked in the metal salt solution, then the dye can directly attach to the fabric through the metal ion. So this type of dye is known as Mordant dye. Here the metal ion act as the, or metal salt solution act as the mordant. The fabrics which otherwise have weak attraction for a dye and are made to be dyed with the same dye using a mordant. The same dye can be used to different colors to the fabric by varying the metal ions. If the aluminium is replaced by other metal ion, the color will be different. Here the color of the material is red because different metal ions form different lakes of different colors. Lakes means the fabrics form insoluble colored metal complexes with the dye. So aluminium gives rose red or turkey red. Barium gives blue color. If barium is the metal ion here, it gives blue color. If magnesium is the metal ion here, it gives violet color. Strontium is the metal ion here, that will give red violet color. So same dye can be used to different colors, that is alizarin can be used to give different colors by which we can change the metal ion from aluminium to barium to magnesium to strontium or etc. That will give different colors of lakes. Alizarin, which is also known as 1,2-dihydroxy anthraquinone, that is 3 benzene ring is attached and one of the middle benzene ring contain 2 CO groups, and here the 1,2 positions contains 2 hydroxy groups, so it is known as 1,2-dihydroxy anthraquinone. Its appearance like orange red crystals or powder. So alizarin is a Mordant dye. Its color developed depends on the Mordant metal ion used because it has a poor affinity or a weak attraction to the fabric. So aluminium ion, which forms a Mordant metal ion to give red color. If iron 3 plus is used, blackish violet color. If chromium 3 plus is used, brownish violet color. So different metal ions with a different color, the same dye will give. It is used to dye the cotton and wool. It is also used as biological stain in medical studies involving calcium, pure ionic form Ca2+, as well as calcium compounds in bones and tissues. Can be stained as red or light purple. If we can use this particular dye as a biological stain in medical studies to detect calcium. If calcium is present in the compound, or we are examining the sample, it can be stained as red or light purple color. It is also used in geology as a stain to indicate the minerals of calcium. If any mineral present in the if any mineral contains calcium, that will be stained by the alizarin dye, that will indicate the red or light purple color if calcium is present. It is also used as a red pigments in paintings. It is also used in making printing inks. So there are several uses. It is used to dye the fabrics. It is used as a biological stain in medical studies and in geological studies to indicate calcium ion. It is used as a red pigments in paints. It is also used in making printing inks. It is in our lab, in our chemistry lab, it is used as a spot test reagent in chemical analysis. Spot test means alizarin is added in a drop in a spot plate. It will give the corresponding color, and we have to identify the ion present without any further analysis. Disperse dye, that is a water insoluble dye. These dyes are applied to the fabric in the form of aqueous dispersion of minute particles of the dye. That means they are applied to the fabric as an extremely fine suspension, and it forms a solid solution of the dye within the fiber that will generate color from the dye to the fabric. 85% of the dispersed dyes are azose or anthraquinone dyes. We know the anthraquinone group is shown here. Here 3 benzene ring attached and middle ring connected to the 2 CO group, that is the anthraquinone group, that is also present in the modern dye alizarin. Example, anthraquinone dispersed dyes are used for the polyamide fibers, that is nylons. These dyes are used for dyeing synthetic fibers, particularly polyesters. Disperse, here we can see a most common dispersed dye, that is Disperse LO42. Its structure is you can see in the picture. Next one is Ingrain dye. Dyes are synthesized on the surface of the fabric are called Ingrain dyes. That means on the surface of the fabric the dyes are synthesized. Example, insoluble azo dyes. Insoluble azo dyes means here any compound containing groups like N double bond N, that is the azo group. So it is a water insoluble azo dyes formed by coupling of the components on the fiber, called, that is also called ice color or Ingrain dye. The fabric is first impregnated with an alkaline solution of the compound that has to undergo diazo coupling reaction. Here the azo compound is formed by the diazo coupling reaction. These are usually phenols, naphthols, aromatic amines or their derivatives. It is a phenol content or a naphthol one or a aromatic amines that will undergo diazo coupling reaction and form Ingrain dyes. The impregnated fabric, that is with an alkaline solution, that will undergo compounds like phenols, naphthol, aromatic amines or their derivatives. On the surface of the fabric, it will form diazo compounds that on the surface of the fabric that form diazo compound, that will give its color by the diazo coupling reaction. The azo dye is formed on the surface of the fabric. These dyes are insoluble in water. They are very fast to washing and light, so it is easily fixed on the fabric. Next dye is sulfur dyes. Here we can see an example of sulfur black dye. Sulfur dyes are the most commonly used dyes manufactured for cotton in terms of volume. They are inexpensive, generally have good wash fastness and are easy to apply. Sulfur dyes are predominantly black, brown and dark blue color. Here we can see the structure of sulfur black dye. Usually sulfur dyes are dark in color, black, brown or dark blue. It is good wash fastness and are easy to apply to the fabric. It is very inexpensive. Red sulfur dyes are also known, although a pink or lighter scarlet color is available, but most common one is dark colored sulfur dyes. Sulfur dyes are water insoluble dyes in the presence of a reducing agent and at alkali pH at elevated temperatures of around 80 degrees Celsius. The dye particles disintegrate, it will breaks and then becomes water soluble and hence can be absorbed by the fabric. Thank you all for listening.